This is to fill any gaps left between the parts after welding. A robot now welds the tapping plate to another steel part called the bottom ring. This ring will hold the gasket, the rubber seal that prevents oil from leaking out as it travels through the filter into the engine. The welded parts, known as the bottom assembly, now go onto a machine that cuts a thread pattern through the center. This will enable the oil filter to be screwed onto the engine. Another press, meanwhile, produces the oil filter's steel body, called the canister. The dies first stamp out a rough canister shape. Then they reduce the diameter and make the can taller. Then they cut off the excess. Elsewhere in the factory, another machine cuts and perforates pieces of tin-plated steel coil and rolls them into tubes. We'll see where those tubes go shortly. Yet another machine prepares the filter's key component, a filter paper that works like a fine sieve, trapping dirt, carbon, and soot. First, the machine pleats the paper so that it'll fit inside the canister. Next, the machine cuts the continuous ribbon of pleated paper into lengths. Then it folds each piece into a circle, fastening the ends with a steel clip. The next machine assembles what's called the filter cartridge. It places each filter paper over a tube. The tube's job is to reinforce the paper against the force of the oil pumping through it. The next machine glues a capping disc on each end of the filter paper to hold the tube in place. A heater cures the glue. Now for the final assembly. As the canisters go by upside down, automated arms insert the filter cartridges. A worker then puts a thin rubber disc on top of each cartridge. This disc will prevent the oil from draining out of the filter. Now for those bottom assemblies we saw them making earlier. A worker positions one on each canister. Then a machine called a seamer folds its edge down, forming a rim, just like the rim of a soup can. Now the conveyor turns the filters right side up as they file by 5 nozzles spraying powder paint. An infrared oven dries the paint in about 90 seconds. Then a printing machine stamps on the product information. The conveyor now turns the filters upside down again as they travel to the gasket inserter. Its automated plungers insert a gasket into each bottom ring. These automotive oil filters are finally finished and ready to do the dirty work. Whether you work in a sprawling corporate office or in a home office, filing cabinets are an essential component of an efficient workplace. They keep your paperwork tidy, organized, and out of sight, yet just a drawer away. And when you're short on space, they make a nifty counter for the coffee maker. Filing cabinets begin as sheets of cold roll steel, a thin type of metal that's easy to bend, weld, and paint. As the sheet comes off the roll, it goes through a straightening machine that removes the curve. Then into a press whose dies punch out the shape of the specific part, complete with holes, slots, and embossments. A filing cabinet is made up of 60+ steel parts. For the top-selling models, the factory has dies specially designed to punch out each part. But that's too costly a system for models that aren't mass-produced. So to make low-volume or custom-made filing cabinets, the factory uses this computer-controlled punching machine. This equipment operates at a far slower speed than the presses we just saw. But the advantage is that it can be programmed to punch out any size, shape, or design, no matter how complex. Several filing cabinet parts are designed to be bent into shape. Workers do that manually using a machine called a press brake. This particular part will become the top of the filing cabinet, so they're making downward folds along the perimeter to create 3.75 centimeter wide edges with strong and tight corner seams. This machine is called a dedicated bender because it's used to bend one type of part only, the filing cabinet doors. The factory produces doors in such volume that it pays to design a special machine to shape them. The doors, too, are bent downward along the perimeter to create edges 1 centimeter wide with tight corner seams. The cabinet's base is welded from the same type of steel sheeting as the other parts. Small steel reinforcements make it rigid enough to support the excessive weight of file-filled drawers. To join the cabinet's sides and back, robots perform what's called resistance welding, fusing metal using heat from an electric current. The next set of robots welds that side and back unit to the cabinet top. After this, workers attach the base using what's called MIG welding, welding that adds extra metal along the joint to create a strong seam. Once again, it doesn't pay to invest in robotic welding equipment for models that aren't mass-produced, so they manually weld low-volume items such as those small filing cabinets that roll under desks. In the paint department, rotary